Hello! After my last video playing with 8-button compasses, I've had viewer suggestions on things to do next, and I've been playing with more magnets myself. This video was inspired by a question from Stephen Brown, which I'm paraphrasing. How about a coil of wire, use a current limiting resistor and a battery in series, pass the energized coil over, under, around the line of compasses, and I guess see what happens. Let's get into it. In the last video, I showed a few fun things that I got these compasses to do. How they lined up with each other when put in a line, and moving fixed magnets past them. In this video, we're going to try a few more experiments. First, we're going to try and build some electromagnets from coils, then a simple circuit to power them. We're then going to see how these electromagnets with the coils affect the compasses. First, I've got a reel of coil wire to make the coils with. I've used it for fine point-to-point electronics work before, but this time I intend to use it for its intended purpose. I know, right? This 72-in-1 science kit. It's just being used as a simple circuit build area. A multimeter so you can check what's going on. Chunky magnetic bolt to make a metal core electromagnet. In the last video I was using these little geomag magnets. Geomag also has these handy cylinders and some end stops for them, and I think these will make for perfect electromagnets. They look great for wrapping a coil round. A bit of a masking tape reel that's nearly empty to make a wide diameter electromagnet. Also need some cutters just to clip off the end. I'll get to why we need sandpaper and why we need a bit of sticky tape. And of course, this big bag of compasses. Let's make an electromagnet. One thing to know about this is not bare wire. It has actually got a varnish on it, so it's not just going to short across being on this metal bolt. So first I start at one end using the bolt head as an end stop. Thread that through there so it almost kind of locks itself. And then I start winding. Now as I wind, so I wind them a little bit wide, and I can push the coils nice and tight. So we've got 4 turns there. I didn't account for how hard it would be to do this in the threads. I'm going to try putting some tape around the metal bolt first. It doesn't actually have to be in contact with it, just has to be the core. Okay, I'm going to unwind this. So for my second attempt, I'm going to wrap this metal bolt in a little bit of masking tape so it won't get caught in the threads. And I'll just tear that off because it doesn't need to be particularly neat. We'll try that again, so I'll hook that round the top like I did before. Okay, I've done 50 turns there. I'm going to clip this off just here. And just because I don't want my hard work to unwrap, I'm going to go and take a tiny bit of tape around the ends. Tear off a little strip there. And I know I'm hiding the beauty of the hand-wrapped coil there. Oh well. And I'll just get a smaller bit of tape. Nice! There's an electromagnet, if ever I saw one. Before I can use this, I need to ensure I get a good connection. I've got about 50 turns here, by the way. It's a shame. I've got these rather lovely engineer wire strippers, but they're not going to do anything for this varnish. comments below if you know a better way of getting this varnish off than just sanding it, a less annoying way. Anyone with a bit of patience can make one of these, really. A bit of patience and a coil of wire. And you wouldn't need the tape if you had a nail and you had a bolt to hand, but a nail would do even better. Let's get the multimeter, and I'm going to put the multimeter into continuity mode. Let's just make sure we've got a good connection on both sides of this coil. Alright, that's a good strong connection. Here's an interesting point. If I switch to resistance mode, and then I put my multimeter across these two wires, that's 0.6 ohms. An electromagnet is basically a short circuit, so we're going to need some other resistor to make sure this doesn't just destroy batteries and destroy itself. So just bear in mind when playing with them, they can get hot, because if you've got current just running straight through it with no other resistor, it's going to get hot and it's going to burn you. So be sure if you try this out at home, please use a resistor, because otherwise it's just a short circuit. So that's the metal core electromagnetic done. Electromagnet. I also made a plastic one earlier using the Geomag bits, and this has got around about 110 turns. Finally, I'm going to turn this reel of tape here into a wide magnet. So let's give this only 10 turns. It's kind of specifically what the viewer asked for, so let's try that as well. So take a strip 1 and strip 2. If I just plop that under there, there we go. That should be 10. Let's put some there. Stop it unwrapping too soon. Trim this side off. Oh, this one's a bit short. Maybe I should have left myself more. Roll of tape turned into an electromagnet. Okay, let's test this one as well. I'll put it back into continuity mode. I always beep it just to make sure everything's connected properly on the multimeter before I assume it's my other device that's wrong. Yeah, that's good enough. So we have 1, 2, 3 different electromagnets to play with. We got 10 turns, we got 50 turns, we got 101 turns, we've got a plastic core or no core, so you can see right through that one. We've got this one as well, you can see right through. This one's a big wide one, so you can put things more in the middle of it. And then we've got this little tiny tight compact 50 turn thing with an iron core. So I guess now we need to go and put them in a simple circuit to power them. My simple circuit, I'm going to take two batteries in series. Got this longer wire here from the battery up the top here down to the on-off switch down here. I'm also going to be using some croc clips, so we'll see what we do with those again. 6 volts here should be enough. Because these are just bare wires, I'll get some clips. Now, I don't actually have any plain croc clips. I got these fancy things that Maplin used to do back in the day, which was 2 wires with a bunch of different endings, and they have croc clips, they have banana plugs, they have circuit hook things, but I'm just going to use them as croc clips. I should get a bag of just croc clips at some point. Which one are we going to start with? We've got the switch. I nearly forgot. We also need a resistor. Positive terminal. We'll take the 100 ohm resistor. So 100 ohms gives us what vehicles IR, gives us 60 milliamps. Shouldn't be destroying anything. And maybe I can try a lower value from somewhere in my boxes if this needs to be a bit punchier, if it's not doing a lot. So let's wire that in there. Croc clips don't work all that well with the spring terminals. I mean, they will damage both if I try to clip them on. However, I've got a little trick. So my trick is to use a short length of wire, like so, and then attach the clips onto there. We'll attach those to this plastic larger electromagnet. So we'll wire one of these here, the other to here. Just to check that we're all playing ball, I'm going to take my multimeter to make sure all the connections are good. The two terminals here, so just make sure my multimeter is ready to go. This one here, and that's going through the coil. So I know my connections are good. Righty, now we get the exciting bit. Before I turn it on, let's get some compasses. So I'm going to take my compasses, I'm going to stick one here, one over here, one here, and one here. So now we can turn on the electromagnet. Nothing much happening there. Let's try putting a compass right next to it here. It's doing something. I can't help but feel either these batteries are a bit low or that resistor is a little bit on the high side. So I've got a couple of other resistors. So we've got 47.0, we'll call it 50 for rounding. Give us 120 milliamps and 10 ohms, which should give us 600 milliamps, so 0.6 amps. I'll only come out with these a bit later, and this is going to be a really cheeky use of this board. I'll pop that in there. And look, it's not going to actually interfere with any of these components because they're not wired in for real. Let's see if this being a bit punchier makes a difference to what happens over here. Flicking the switch. So they're all moving. It's not exactly a violent reaction. Should we try the 10 ohm? 0.6, that's nearly an amp. Now it might be also that these batteries are getting a bit weak. So put this into volts and measure that and we get 6 volts. Okay, right, so I've put these kind of close as I can get them, and we're out on the small 10 ohm, so 0.6 amps. There it is. Wait for them to go back. I'll put this one over here, and that one goes as well. Okay, so we've got a nice clear reaction from those compasses. We just had to dial down the resistor so we could dial up the current that was going through it. There you go, it's a current controlled device, so you need voltage to push things around, but current is what appears to give you field strength. Okay, so let's try it with the smaller metal core. Being smaller, I'll be able to move this around and get the compasses much closer to it. This has only got roughly half the turns of the plastic core one we were using before. However, the metal core should give it some more strength. So let's pop those on there. Connection there, not doing bad. And I'll do my same trick with the multimeter in continuity mode. So this one is connected, and I'll put these much closer in and we shall see what it does. So the other thing is, by the way, I know it's got fewer coils, but I've not tried to measure this, so maybe a later video. Right, let's turn it on. Whoa, there we go, that's nice. And we can try that again, let them all kind of dial down a bit, and oh, look how long it took that one to come out there. So it obviously has to kind of collapse. Remember, they talk magnetic fields, they kind of build up and then collapse, so they don't just go immediately. So we'll do that again. Turn it on. Alright, we got 1, 2, 3, 4, 5. I mean, it took about 4 seconds for this one to go, and this one might just be a bit stuck anyway. And that one might be a bit of a dud. I've just realised that might be a dud compasses. Some of those compasses, those button compasses, weren't great. These were cheap as. And now they're affecting each other, because compasses do, because they've all got magnets in them. Turn it off. 1, 2, 3. There we go. No, it's not going. This one. Ah. Maybe I have to wait. Okay. 1, 2, 3, 4, 5. I need to tap. See, they are going. I wonder what will happen if I take another wire and just short the ends of the electromagnet. Obviously not my batteries. So the batteries are turned off. Nothing much. Okay, let's turn it on. Turn it off. See, they kind of slowly go back. Presumably these are following magnetic field lines. Let's see if I can make 2 lines of them. And this is where it's going to get tricky just because of, well, where everything is really. 2 lines of compasses, and turn it on. And they all go. Now, is there any heat in that? There's no heat in any of this, which is good. Oh, yes, there is. Oh, that resistor, 10 ohm resistor, that's pretty hot. Yeah, ouch. So something in this does get hot. I suspect, I mean, it's only 600 milliamps, but I'm not quite sure how many watts these resistors are good for. But I guess if we've got 600 milliamps multiplied by 6 volts, that's what? Is that 360 milliwatts? And these resistors might not quite be up for that. So something to be aware of there. There's a bit of a trap there. The other thing we can do with this, because we've seen what it does go in one direction, I'm going to try reversing the croc clips. So I'm going to leave that arrangement on the desk there. So we'll take these croc clips, reverse them. Oh, I did nudge the desk. Oh well, okay. I turn it on. They'll all spin the other way. Now, that's pretty cool. And I guess if I could do, say, a little H-bridge circuit here with a kind of a 2-pole switch, double pole, double throw kind of thing, then I could kind of get it to reverse on a switch and you could see them spinning the other way. Maybe for another video again, I'll try and get that and we can get them to spin. We can also then take the compasses and maybe make a little grid of them. So what I'm going to do, and at the risk of that resistor getting a bit hot, so I'm going to watch out for that. Let's turn it on. Oh, oh, I smell burning. And batteries are fine. Coil is fine. That resistor's about to go. Interesting. Alright, what I'm going to do then is take another one of those 10 ohm resistors, put them in series, double it up, half the current. Clearly I am pushing it at 600 milliamps. So this double up should make it 20, which should give us only 300 milliamps. So that should basically halve what I'm trying to get the resistor to handle. Okay, let's see if this still does anything. Oh, we wave it around. There we go. We see them going. And I'm just going to tap out. They're still hot, but it's not nightmarish. Again, with coils, just be aware they get hot. The other thing that the viewer asked me, Stephen Brown asked me, was to try and wave this around underneath. Now, I'm carefully wondering if this is going to get a bit toasty for my fingers, but we'll find out. Right, so I'm waving that around underneath, and you're seeing them moving. It's kind of going. There we go. The interesting thing here, when you think about how this is going to work, if you've got more turns of wire, you're going to get a stronger magnetic force, but there's going to be more resistance in those wires. So you'd probably have a lower current and less heat going through the circuit. When you have fewer turns, like this thing here, which we're going to try in a minute, it'll produce less magnetic force, I suspect, you know, compared with, say, this or this, this or the... but it's also going to get hotter. It's going to make the resistors hotter. So maybe with fewer turns, I need higher resistance, which is a shame because it means I'm going to get lower output power, I guess. We're going to give this one a go, the wide diameter, which is what Stephen specifically asked about. And also, I think what I'm going to do is start on the 100 ohm resistor. So what's different from this magnet with this magnet and the other two, because it's got a wider diameter, is I can put stuff in the middle of it. The plastic one you can put something long and thin in the middle, but this one I can put a compass in the middle. So different experiment, I can see what happens. So the others, you know, I was laying them across things and next to things. This is more like putting it axis on the compass. Let's just use my multimeter. Make sure, I'm just going to tap them off. Yep, that we've still got continuity. We have. Oh look, if I put it next to one of the coils, one of the sides. Kind of. There's a movement there, but it's very slight. And if I put it dead center, There's nothing doing. Okay, let's try the 50 ohm. Nothing in the center. Okay, if I put it on the outside, I mean that's very marginal. What about if I put it at the back here, just so that it's not going to be aligned to north at all? Turn it on. I mean, it's happening. Not as dramatic as I was getting with the plastic magnet, or indeed the metal magnet. So it's kind of not as much fun. But wait a minute. What if I put it up this way? Turn it on. There's not really enough going on there. I'm afraid to say 10 turns didn't really appear to do a lot. I can try it right up on the 20 ohm, though I think things are going to get pretty toasty on my electronics board if I try the 20 ohm. But let's give that a go. Let's put this around the outside and see if anything happens. Are we ready? I'm going to get ready for things to get hot here as well. So ready for burning smells. It goes. And there's not too much heat, so it does go. Okay. So I guess in the middle there's not going to be a lot going on, because I suspect I'm expecting the magnetic force line to be going either up or down depending on the polarity, and not going this way or this way. I don't expect any reaction that way. However, just beside it, and turn it on. Yeah, we got something. What about trying this one under the desk? Now we got something under the desk with the metal core. I didn't really try it with the larger plastic cord one, so maybe that would be a better candidate for going under the desk. Turning it on, and there's a nice clear reaction doing under the desk. Let's put a bunch of these in a grid. And what about if I wave it around up here? So let's turn it on. You can kind of see them going as I move it across, but when I put it underneath, that's kind of cool. So we can get it to do stuff under the desk. I don't think we can get it to do anything when it's axial, but let's try that anyway. Oh, no, that's doing stuff. Okay. The best thing would be is if I could have this many turns on a nice metal core like this. But there's more we can do with a metal core. This should so be in another video, but I just can't stop myself trying this. Going back to Geomag, it comes with these metal balls. Can I get it to pick up the ball? Or even to attract the ball even slightly? Come on. It's getting hot, but it's not doing it. When you get the Geomag magnets, they attract the ball very clearly. And we saw how they made the magnets do stuff. So, oh, now I've stuck that on there. That permanent magnet. I wonder if I can get it to repel it. It's just not strong enough to have an effect that way. This one, let's try it. Again, no metal core, but twice as many windings, and actually it's a wider magnet, so it should have probably about I don't know, 4 times as much wire, maybe a bit more. Let's try this one and see if it has any effect on the ball at all. No effect at all on the ball. Okay, what about if I stuff that magnet halfway in here? Alright, if I find something to prop this up on, like that perhaps, pop this in here, can I get some sort of action when I press the button? I'm going to go down to 10 ohms, 600 milliamps again. Going to get very hot, I think. Very hot indeed. Actually, I better check that these batteries are still putting out, because I've probably given them quite a hard time. 5.95. The battery condition of these is getting worse because that heat obviously was coming from somewhere. And again, this is why I say these coils are like a dead short. Oh, let's balance that so it's just in there like that. Ready? Turn it on. Okay, what about if I go put the magnet in the other way? That was it. Let's pop it back in again. It does work, but not always. So there's been a load of fun experimenting with electromagnets and compasses. Thank you, viewer Stephen Brown, for the idea. I've got ideas for more experiments with this. Maybe making some bigger magnets with bigger batteries. Making things move a bit more and picking stuff up. Maybe seeing if I could generate electricity with a little handle or something. Trying the coils and fixed out magnets out with some magnetometers. So measuring stuff like that, and I can measure what the magnetic strength is. There's a reed switch here on the electronics kit. Reed switch over here. And there's an FM antenna here, which looks a lot like a coil to me too. So look, let me know if in the comments if you've got any other ideas to try, because this is kind of fun. And as I always say, go make stuff and be awesome. Bye. Did I destroy anything here? Well, those resistors got a bit toasty. I think I've destroyed batteries and resistors.